Hello and welcome to another tutorial. So this is actually going to be the first in a series of ones where what I want to be looking at is building up a system where we can load up a simple level, so a level that's just going to be constrained to a plane, so largely 2D in that regard, but a level that we're able to load from a file. And so we've got a bunch of different things that we're going to be looking at associated with that. And we'll eventually piece together more and more aspects of this. So what I want to focus on today is how we can actually find that file, how we can load up the stuff from it, instantiating things in the world, and a bit of an architecture for how to approach this. So to begin with, we need to actually have quite a few bits of sort of scripting logic happening. So I'm going to set up for the script, well, one of the big things, I need something that can load the levels. So I'm going to create a folder called Parser, and this is going to get a script in it called level parser. So that level parser is something that I want that to be on an object sitting in the scene. So level parser. So anything that gets instantiated, I want that to be sitting under the level parser. And I'm actually going to have it on a specific sort of separate child object. So level root. So the idea behind level parser is it's going to take in the file, instantiate everything. If something was already there, it'll clean out those things as well. So a couple of things it's going to need to begin with. Well, it's going to need access to that level root. So we know that we're going to have a transform level root. And so that's something we're definitely going to have. So we'll link that up to begin with. And then what needs to be able to load the file. Now I want to set this up so that those files, we could add in additional ones at runtime. So this would allow you to have, a level editor built into the game, or people could go and modify the existing levels. So stuff like that would be really great to support. So to be able to support that, what I'm going to do is I need the files to be in a particular location. So I want them to be ones that I can very easily just throw in new ones in the build. Now we could load ones from multiple locations as well, and that may be a thing we end up doing at a later point, or there might be additional levels I download. So what I'm going to do is I'm going to create a folder called Streaming Assets. Now, if you've already got other stuff in the project, you might actually already have a folder called Streaming Assets. So streaming assets get processed a little bit differently, in particular when we create a build. So normally when we create a build, Unity will grab all of the files, it's going to be doing some processing on them, and it kind of smushes them together into one archive. That doesn't happen with streaming assets files. Those get left standalone, and you'll actually, if you look at the build folder that gets created, there's a streaming assets folder there. So you'll see this gets used a lot of audio middleware, things like if that use it. Now that streaming assets folder is not necessarily one that we might be able to write to on like of a mobile device. We typically wouldn't. But it's something where it gives us an easy one during development. We can throw in files there. It gives us an easy one where we can be testing and working with that. And supporting files, level files located in another folder is quite straightforward. So we're going to, under this, create another folder called levels, because we might have multiple things under streaming assets. And to begin with, I'm just only going to support having a level with a specific single sort of file name. Now, this isn't going to support us being able to create a particular type of file necessarily, because it may not be we might want a custom extension. So under the levels, there's not going to be a built-in supported file type here because we're creating our own sort of custom file type. So none of these ones are going to work. But what we can do is if we go to this folder, then I can create my file. So I'm going to, good starting point is just a text file. and I'm going to call this level 0, and we could keep .txt as the extension. We could go for .level, we could go for LVL. The extension is really, that only has meaning to us, so it doesn't really matter what we use there for that. I would generally go for having a specific extension for it. Reason being is that it makes it easy if you've got lots of different files that might have a similar name to distinguish which ones are which. So I'm going to call these a LVL file. And then what I can do is I can load that up in Visual Studio. And so now it comes down to what do we want this format to look like. So there are established formats where you could use things like XML. You could use stuff like JSON. So there's lots of different ones we could use like of that. I'm actually going to use kind of a bit of a hybrid format. So something if we're laying out a level on a regular grid, which that's what we're doing in this case, it's on a regular grid. That's something where in something like a spreadsheet, it's very easy to edit levels then, because it's a regular grid. You can very easily visualize them in a spreadsheet, can really speed up iteration time. So comma-separated values is a really great potential option. But the downside with that is there's generally going to be extra information we want to bake into a level. The reason being is that there's might be version info, there might be stuff like objectives or scaling settings or theming settings for the level. So we want to be able to support extra content. So I want to be able to have a section that is going to be, might have level and end level. And in between those, I might have my actual content. And then what I could have is something where I've got sort of common settings. So we could have metadata, and I'm putting in end tags, and I would generally have stuff be case sensitive. So that looks all right. And I could initially put in some stuff here. So version equals 1. And this, I might actually want to change this so that, well, this one isn't level and end level. It's actually layout, because that's more describing what it's doing. So we've got a bit of structure to it. That structure means we've got things we can be looking for when we're parsing the file, which is great. We've got already support for these different sections, which having that support for those different sections means that we can then easily add in additional sections in future that we might need. Now, in terms of layout, I need to have some things that are going to be getting spawned. So I want to lay this out. Let's just have something where I can have rock. So we're just going to make something super simple. So we'll have rock across the top there. Then we'll have rock. Now for your initial level, I would recommend laying this out in such a way that you can easily tell if something has gone wrong. So if it's imported things at the wrong location, stuff like that. It's going to make things a lot easier. So that's why I want to have water at the top there. And then we'll have a layer of rock down the bottom. But then I'm going to, in between, I want grass. So this is going to tell me, I'll be able to see orientation-wise that things look correct. And if I chuck in a little bit of grass there, now I've got something where I'll be able to tell immediately if I've instantiated things in the correct location. Because if they're in the correct location, then I should see, each row. So these will be our rows, and then these across will be our columns. So that's good. What would also be handy is if I could support comments in this, so I could put extra bits of information in there. So there's different ways that I could go about doing that. I might be able to use something where, okay, if it starts with the pound symbol, it's down to whatever you want to use for that symbol. Pound symbol is a common one that you'll see used in some ones. We could use a double symbol. We could use exclamation mark. I'm going to use the pound symbol. That's one that I often use when I'm doing file parsers like this. So that's sort of a default that I'm used to using. So our metadata section and our layout section. So that's good. So what we then want to do is, well, I can kind of keep this open on the screen at the same time, which is going to make it easier for me setting up the parser. So what I want to be able to do is tell it to load a particular level. So I want to have a function that's something like load level, and we give it level0.lvl. So that function, which this is one that I would make public. So load level, string file name. So we need to get the file path. So that's okay, we can do that. Application has the streaming assets path, so then we can combine that. So I'm going to bring in system.io, because then I can do path combine. So whenever you're combining paths, I always recommend using path.combine, because we can give it the streaming assets path. We know the folder was called levels. So we'll do levels and file name. So this is going to give us the full file path. File path. So I would always just use path.combine. It's going to work across different platforms, works that out much more reliably. So that's good. We've got the file path. Well, I might already have an existing level loaded, so that's something where I potentially do need to clear that. So clear existing level. That can be void. So before I even load the file, I'm going to clear the existing one. So clearing the existing level, I just need to delete any game objects that are children of the level root. So for index is level root, child count -1. So this is a loop where we count down, so that we can then do level root, get child, we grab index.gameObject, and then we just do a destroy. Remove the existing level objects. So just ensures that if there's any existing ones there, we've cleaned them out, which is good. Constructed the file path. So now we need to actually process that file and load the content of it. So to actually load the file, there's a couple of things we need to be doing there with that. And so how I usually would go about doing this is, first thing, if file does not exist. So if this file does not exist, we can't actually load it. So we're going to throw a new, and we have a file not found exception, so we can provide it with the file path. File not found, so that's good. We're handling if the file's not there. Now that we know that the file is there, well, that actually makes it pretty easy. We can do a read all lines of that file path, and then this gives us our file contents. read and parse the file. Now, if we had very, 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 very large levels, we might not want to parse it all in one go. But with this, we're going to be able to parse it all in one go, and you can handle fairly large files parsing all in one go. So with that, we need to loop through all of those file contents now. So for each var file line in file contents. So now, and this is something where it requires a very specific way of sort of designing and handling this stuff, because we are processing stuff a line at a time. So first thing I want to do is there's going to be some lines that we can just wholly reject, and that's okay. So one of the things we can do is file line. So I'm going to trim it. So line to process is that. And then I want to check if that line to process is empty, if it starts with a comment. If it does, I want to be able to reject it. So if string, and this is where we can use the is null or white space. Or we could use the is empty or white space. There's a lot of different ones we could use there. I am going to go for, firstly, if string is null or empty for line to process, because we've already done the trim. So if it's that, or if line to process starts with a comment character, then skip it. Line has no processable content. Now, I'm going to just move this so we've got it up the top here, make it a little bit easier to see everything. Now, I'd want to avoid stuff like of this. So this is where I would do a const char and probably something like a keyword comment, just so I'm not constantly, I'm only accessing it once, but it'd be good to have these things in a common area where I can be checking them. Just avoids sort of potential changing it in one area, and if I do use it in another, it's just good practice to be doing that. So now I need to know what section I'm in, and I need to keep track of what section I'm in. So what I'm going to do is set up here enum the level section. I'm going to have metadata, and I'm going to have layout. So then what I can do here, and also I'll chuck in another one before that of unknown. So E level section. So we do that. So now what I want to check is, well, if the section is equal to level section unknown, then I want to check for things like metadata and layout. If I'm in metadata or layout, then I want to check for their corresponding end section. So this is going to be the core of the parser. That should be equals, not equals. So let's define a couple more ones here. So const string keyword metadata start. And then we also check for metadata end. And then we have the same sort of thing for layout. So this way, what I'm able to do is, well, if we're in unknown, then I can check if line to process is equal to, because we've already trimmed it, should be able to match it exactly. So if it matches metadata start, then section becomes metadata. Otherwise, I want to check if line to process, so not metadata end, but layout start, because then I change the section to that. So R in an unknown section. then otherwise I must either be in metadata or layout. So I can then check here, well, if line to process, if that's not equal to metadata end, then I could have process line, or parse line, I think is a better term. Parse line, metadata, and we give it the line to process. Otherwise, it was the end tag, in which case the section goes back to unknown. And we do a similar logic here for layout, and that's going to reliably give us something that is able to parse this file, but is then doing it in a way that, as you can see, it's very easy for us to add in additional sections, stuff like of that. So then we have parse line, metadata, string line, and we would have void parse line, layout, string line. So we can then test this at this point, just to make sure it's working. So metadata, because this is enough that we would be able to tell, is it successfully managing to actually read the data and keep track of what section it's in? Is it managing to find the file? So this will be enough to tell us if that side of things is working. So if we run this, it should kick off running it, and we can see we got our metadata being output. Now we got layout, it actually got an end level 1, so that potentially means that within layout it did not properly match that line to process. So we just want to check that here, that should have set it to unknown. So easy to miss when you're doing a lot of stuff like this. There's a lot of autocomplete happening. Very, very easy for that to stomp over things. But now we get our metadata, so that's good. So we've got that information. Now we can start to store that information somewhere. So what I'm going to do is I'm going to create a script that I'm going to call level. Now this is not going to be based off of mono behavior. We'll let it load up and we'll make sure it's down here. And this will not be based on mono behavior. And it will, though, keep track of stuff like the file path, things like of that. So we're going to have things here like its version. And we'll have stuff like its file path. And I'm going to give this a constructor. It's public level int version and string file path, so we can then populate those. So that will be something that what we'll do is once we've processed all of the metadata, we'll actually create our level. So I'm going to have here level, new level, equal to null. And then we're going to need to be populating that with information. And pretty much as soon as we've got the version, we could actually create that. And that could also be something that we could set it up piece by piece. So we could already have this where we create a new level and we give it file path. And then version might be a thing that we set afterwards. So that's the other option that we've got. So we could have void set version. Now, it's generally not going to be a case where the level would need to know that, but potentially useful to have. So we've created our level. That's going to be something that's available, and that would be a useful thing actually to parse to these different sections, where it can be a case of, well, here's the data to process. Also, here's the current level. So level, pass that through. So metadata, we have structured that in this manner, where we've got a key is equal to a value. So that's good. What we can actually do some very straightforward splitting up of that. So what I would do is line split, and we can tell it we want it to split it on the equals. Now we do have a bunch of string split options where we can do things like remove empty options, stuff like that. I'm just going to stick with the default. So this is going to be the key value pair components. So first thing I would want to do is check, well, if KVP components length is not 2, then something is wrong with this. It doesn't actually match the required setup that we have. So I'm going to throw. Now we could set up a custom exception for this. We could just throw a generic exception. So we could throw a generic one, and we can provide description with that. So it does support giving a message there. So I could be saying invalid metadata expected format key equals value found, and we just give it the line. So check if the metadata is invalid. Now, if it is valid, then we can start checking the values for it. But again, we want to have some key stuff here that we could be checking against. So this is where, because this is all tied into the metadata, I would actually usually do something like class metadata fields, and then have something like public static string version. Because then down here, I can just do a check. Okay, well, if KVP components 0, and this is where for neatness, I would do stuff like key is KV component 0, and we do a trim for good measure. And same thing with the value. So then I could check, okay, well, if key is equal to metadata fields version, then level dot set version int dot parse value. So now I'm populating in the version data. Check the key. If I had lots and lots of different keys, that's where I could use something like a switch potentially. So option I use there is going to be dependent upon which ones, how many different ones I've got. If I've only got 2 or 3, I'd usually use an if. If I've got several, I would use a switch statement. If I'm expecting several, then I would use a switch statement. But it's very easy to convert over. So now we've got these layout ones. So we need to convert these over and start extracting data out of that. So with these, we've already got explicit sort of row column setup happening there, which is great. Each line is going to correspond to a row, which is good. And then within a row, we've got the different elements. Now, that's something where at the moment we've just got one thing in each cell, but later on we might have more than one thing in each cell. So what I want to do is I'll split it by comma, but I'll process these in such a way that it would be easy for me later on, if need be, to actually set up separate sections there if I needed to. So what I'm going to do is a couple of things. Now, not all of these will actually fully sort of work yet, but that's fine because we'll add in extra stuff as we go. So firstly, I want to split that line. And just like I did up here, I want to have const char keyword, and column delimiter, which is just going to be a comma. Could use any other character if you want. Comma is the main one I always use. So we split based upon that. So var, and this is going to be row elements. So, okay, that's the elements in each row. So then I want to process each row element. So, okay, for each var element in row elements. And this, I'm going to call that raw element. So I can have element is equal to raw element dot trim. So process each entry. Now this could be empty. So that's something where that is something at this stage that I don't want to treat as a valid entry there. So I'm going to say, well, if element, and I could do the string is null or empty. If that's the case, then I'm going to throw an exception. So throw a new system exception, and we'll throw one empty element on line, and we provide the content of the line. So we don't want to process empty elements. So then I need to work out what thing I'm actually processing. So effectively I need a registry that maps to these things. So this is where, how I would normally set this up is I actually usually will use something like scriptable objects for this. So I'm going to have a data folder here. And then under scripts, I'm going to have a folder tiles. And we're going to have a C# script that this is going to be base tile behavior. So this is a way of using scriptable objects that you may not have seen before. It's something I'm using a fair bit these days. I find it works really well, where these scriptable objects are going to have a lot of logic embedded into them. So there'll be base tile. We're also going to have a tile then, so we'll have a rock. We will have for grass. And then we will also have for water. So we'll just load up these and get these properly configured. So it's again, unfortunately putting things there. I will bring the level down because we're not working with it to the same extent now. So these are going to be a scriptable object. Now with this, there's going to be information from this that I need to be able to easily access. So what I'm going to do is I'm going to say that all of these have a particular unique ID, and that's what's going to be looked for in the file. So for a rarity, I'm going to make this a public string unique ID. And then all of these other ones are going to inherit off of this. Now, I'm not going to set up the create asset menu for the base tile behavior because it shouldn't have that. So these will be base tile behavior. Get rid of these. And we have our create asset menu, menu name, tile water, file name, water. So we just set this up for each of these, and that will mean we can create those scriptable objects for them nice and easily. So because it's a scriptable object, we won't have start and update. So we can get rid of those at the same time as when we're updating the entries here. So that's good. We've got our different ones. And then what we do is in our level parser, I set up here a serialized field list of base tile behaviors and supported tiles. Then I set up a dictionary, and that's going to link to that, and this is going to be the tile registry. So it's a new dictionary. Now, dictionaries are weird in that sometimes they end up serializing. So I'm going to be really explicit and mark it non-serialized. Then in start, actually I can do this in awake, I can build up that tile registry. So all I do is I just go through each tile in our supported tiles, and then tile registry, tile.uniqueID is equal to tile. Build the tile registry. Then down here, I can check, well, if tile registry does not contain the key for element, and throw system exception, unknown tile found. So we're making sure that if that element is invalid, that we won't process it. What I will do here is just a debug log found matching tile, and we can just use tile registry element. So that should mean we get a bunch of output, and I'll get rid of the layout debug. We don't need that anymore. This is something we can then just create our grass, rock and water ones and make sure we can load those. So we'll have grass, rock, and water. So we just set up our names for each of these. And then in our level parser, I'm going to add in grass, and I'm going to add in rock, but I'm not going to add in water, and that should mean we get an exception where it says, no, you're mentioning this thing that doesn't exist. And we did, we got an unknown entry there. Now it has gone and put out the entire element there. So that's because keyword there, we're splitting by the wrong one. So this is why we chuck in these errors and exceptions to begin with, so that we're getting a clear indication. So this time, it failed to find water, which is what we expect. So we can add in the water tile, and now it should run, find all those things, and we should see no exceptions, which means we can start having this doing stuff. So that's great. It's found those things. Perfect. Okay, so we're in a position we can start creating the individual elements for the row and starting to add them to the level. Now, we kind of have a choice here in terms of where we put a lot of the responsibility, whether we put that more in the level for maintaining where things are, or whether we put it on the parser. There's not necessarily a right or wrong answer for it. I generally default to putting stuff in the parser, is usually my approach. But there's not necessarily a right or wrong process for that. And sometimes you might want to have a little bit of a split responsibility for it. So for example, if I was going for a split responsibility one, so I do usually go for in the parser or a split responsibility, what I could be doing here is I know what I need to instantiate. So I could go, hey, well, level, add tile, and tell it the particular tile to add. And then I could also have stuff where I've got, well, level, add row, because it needs to know that a row has begun. So that's information that it needs to have. So what I could do then is in the level, it's going to have public void add row. And then it's also going to have a public void add tile. And we have our base tile behavior, and this is going to be our template or our prefab effectively. So we've got add row and add tile, and we need to assign locations for these. And so this is where we need to decide how we want to organize things axes wise. So how I'm going to do it is I'm going to say the columns map to different x values and rows map to different z values. So that means I need to have here vector2 int insertion or current insertion point. And what I would do is when I go to add row, well, this is going to start at vector2 int 0. And then when we add a row, that's going to then go, okay, well, current insertion point is a new vector2 int at current insertion point dot x plus 1, though that would add to the column, so it would actually be 0 on the x, and current insertion point dot y plus 1. So that adds in a new row. Whenever we finish adding in a tile, then we would do current insertion point dot x plus equals 1. So now we can instantiate our tile here. So we can do scriptable object, instantiate, we give it our template, and this is our new tile. So I need a setup here where I can be keeping track of all of those tiles. And I want to be able to easily retrieve them based upon location potentially. There's lots of different things of how I might want to have this structured. So what I could do is I could have a list of tiles. Now this is going to be the easiest for us, being able to work with the fact that we don't know the size of a level to begin with. So this is going to make it that we've got, it's easiest to adapt, and even the different rows could have different lengths. So this is going to be our tiles. So we instantiate that. Now every time we add in a row, what we would do is tiles add new and a list of tiles. Then when we instantiate one, well, new tile, it's equal to that, and we would go tiles current insertion point dot y dot add new tile. So instantiate the new tile and add to the level. Well, now we need to tell it that tile probably wants its location. So new tile, and I might use bind because there'll be other things I think I'll want to actually put in here, and current insertion point. So that means if we go to our tiles, they're going to get a public void bind vector2 int location, and we'll just set this up so it has a public vector2 int of location with, this will be a protected set because the child classes, we want them to be able to access it. So location has now been set. So that's good. We've set its location there. Now we haven't actually created anything in the world. So these tiles actually need a prefab because these are scriptable objects. They're not something that exists there currently within the world. So I'm going to set this up So it has a serialized field, game object. I'm going to do that as a prefab, and I want this to be protected. So that I'm also going to set up an accessor for it. So a game object prefab, which I'll just link to that. So we need to instantiate a prefab in the world. So that's something where I can set up a couple of prefabs that these will be able to set up. So these behaviours. So what we're doing is we're actually splitting the behaviour kind of from the visual element. So tile prefabs. And what I'm going to do is I'm going to keep it simple. The tile prefabs will largely just be a cube. Now, what I'm going to do is give those an empty parent. And this will be called stuff like tile rock. We'll also have tile grass and tile water. Now, these might need some actual logic sitting on them. So I'm going to, again, set up another folder here for behaviours. And we'll also have one that is essentially the in-world game object for the tile. So something that's just wrapping around it. So this is going to be instantiated tile. And we're just going to add that onto each of these. So it's going to be, because there's likely going to be stuff where we do need to be able to retrieve that. So it's just going to make life a lot easier. We'll also set up a folder for some materials. So we want to have just a couple of simple materials, mat, tile, and we'll have rock, we'll have grass, and we'll also have water. Let's just give us our base set of ones. We'll do a quick little bit of coloring on them. So we've got them standing out. Just so we'll be able to know that we've instantiated the correct tile. Then we'll just link up the materials for these. So we've got our water one, have grass, and we will have rock. So each of those are set up, means we can create our prefabs. So these are what will get instantiated. So the behaviours will link to those. So grass links to tile grass, rock links to that, water will link to water. So this will just change what it instantiates. So there'll actually be two parts to the instantiation process. One is this stage of creating these individual objects, and so the scriptable objects, and then there's going to be the actual creation of the in-world game objects. So there'll be different stages to what we actually do for this. So set the location. So that's good. Now we can start to get the rest of the bits here up and running. Because once we've parsed all of the layout, once we've reached the end of the level, well, that level we need to actually instantiate it. So we've loaded the data. So we've got all of the game world data for it. We just then haven't actually made it do anything yet. So what I want to be able to do is this new level here. I want to go make level active, new level. And what that's going to do, I'll actually create this. We'll have a setup here of level active level. And then when we go and make that level active, so void make level active, level new level. So we could check if active level is not equal to null. This is where we could do any cleanup. And cleanup if needed. Existing level present. Otherwise, we can go, hey, active level is new level. And so we haven't spawned any game objects yet. So we've set up those prefabs. We haven't actually spawned them. We know where they should spawn in the world. We haven't done anything actually with them. So we could then go, hey, well, active level, form instantiation. And we could give that the level root. So it knows here's the starting point for instantiating this. So we'd have public void form instantiation transform level root. So now we've got to go through our rows. We create our rows. We need to then create the individual entries within that. So, okay, that works. Well, for each var row data in tiles, the first thing I want to do is create the game object for the row. So var row game object is a new game object. We want to make sure we give it a name. Really important to make it clear and easy to tell what sort of row we're currently at. So that would mean I need to keep track of the row index. So that's actually something where it's going to be easier to just go, well, row index is 0, row index is less than that. Then I create one, and I can just say, well, this is going to be row, and we add 1 to it, so it starts as not being something that's 0 based. So we create that game object. We want to parent it. So we're going to say, okay, well, row game object, your transform parent, we could just do transform set parent, and we want to set that to the level root. So we've created the row object, we've set what its parent is. We want to position that row game object as well. So row game object and its transform, we would say the local position. Now that's going to be a new vector 3. Now rows, we said we're going to be in Z. So then be row index times by, well, we need to know the block size. So we're going to have here float tile size, because we have to know what the actual spacing is between them. Now I would recommend keeping that as being something like of 1 if possible. That's going to tend to work pretty well. So we'll set this up so we have, and I'll put it above here so it's not missed. Tile size is 1. So that's something I would generally recommend keeping. I think that tends to work a little better. So here we have created the row game object. Now we create the individual tiles. So create the individual tiles. So for tile index is 0. And this is where we can grab out var row tiles is going to be tiles at row index. So we're looping through. So tile index is less than row tiles count plus tile index. Now we're going to do a similar thing where we create a game object. And the reason for that is we might want to have multiple things within the same tile. So this makes it a lot easier for us being able to set that up. So what I would do is largely use this except rather than being row, it's going to be the tile game object. And we'll make it tile. I want to keep the row index in there, so I'm keeping that. And then I'm just going to add in tile index, also +1. Now the local position, this changes to keep that as 0. But in this case, we have tile index times by tile size. And the parent is actually the row game objects transform. Okay, so we're now ready to instantiate the behavior. So what I'm actually going to do for this is go tiles, and so actually row tiles, it would be row tiles, tile index, and I'm going to let it do the instantiation. So instantiate tile, instantiate behavior, and I will give it the tile game object. So it knows what game object it's going to be parented to. So then this public virtual void instantiate, and we give it game object, game object. So we instantiate this. So it will be a case of, okay, well, game object instantiate prefab whole game object transform. So we're setting the parent. So this can then also keep track of, we can have a public, and we'll have game object linked game object, and that will be get a protected set, so anything is going to easily be able to access it. So we'll go linked game object is that. Now we already put a bit of scripting on this where linked game object, we should be able to get component and our instantiated tile. So that's something where if we want to, we could be caching that, we might need to, or we might need to have communication happening in both directions. So this is something where what I would do is public instantiated tile and linked tile. So we can just store that because that's going to be useful. And then we can go, well, link tile bind to this. This will just allow two-way communication there. So our instantiated tile can keep track of. So we'll have a base tile behavior, linked behavior. And then the bind function and just link that up. This just means we've got two-way links with everything, so it's going to make it a lot easier for being able to have communications happening if we need. So in theory, something should happen when we run this. So let's find out. What we're hoping is we get level. Now, running into issues, absolutely a possible thing. So what would actually be happening there is our current insertion point, that would start out at 0, and as soon as we add a row, it would go to being 1, which is not going to be correct. So what I could do is I could have it that when we do add row, it does absolutely correctly do that. And then I have a public void end row, and it's the end row that shifts the insertion point. So then in the level parser, what I do is after it's actually parsed a row, we do level end row. That'll just make sure it's updating it at the correct point in time. So now if we run this, so if we take a look at this, and if we go to our scene view, so what we're expecting is, in terms of orientation, things should be oriented where we have our progressively increasing z-axis. So we're in global coordinate system. So z-axis, we've got our different values here. So that looks good. But you'll notice this, if I compare this with our level, it should be grass and then water should be at the top. And that's because of the order that we've got stuff in. It's an inevitable thing that you'll run into with this, where the row order that we've inserted the rows in is from the top down. So that means that the row order actually ends up being a little bit flipped. So that's okay. That's something that we can fix. So we do have different ways that we could resolve this. We could entirely flip the data. That would be something that would be an option there. So we could take all of the rows, reorder them. That's absolutely a viable option that we've got there. The other thing that we can do, it's actually quite a simple change for this, is where we're instantiating the rows, if we put a minus here. So remembering what the layout should look like, we should have rock on all sides, and then the top should be grass, water, water. That's what we're expecting to see. So let's run this with just that one change. And we can see that does it. That's quite straightforward for us being able to fix things like that. And now with our prefabs, we can start to do things like, okay, well, our rock one, I want to actually have this be higher. And so because of how we've built the mesh and everything for this, that's actually quite easy for us to do. So I could make something here that is taller. We update its position. And then immediately with that, we have higher rock walls. I could, if I decided, no, that's actually a little bit too tall, I could lower that. So it's actually more like 1.5. And I could take the water and I could actually lower the water height. So I could say, well, yeah, no, that's a bit too high. I want water to be lower. So then with running that, we can just have, we've got water is lower, we've got grass there. So immediately we've already got differences there. So that's good. The other thing that then quickly want to add in is a final bit using a little bit of stuff with the behaviors, because I want to actually be able to have the levels tick, but the logic is going to be on these behaviors. So what I'm going to do is for the behaviors, I'm going to actually say, and I'll make the base one actually can be abstract. What I'm going to do is I'm going to have a public virtual void tick. So whenever I'm doing something where it's being manually ticked, I always use tick rather than using something like update, so that it's clear that it has to be manually run. So that looks good. I just want to check, because we're changing that to abstract, there was always the potential that that could cause issues there with data being stored, but that's fine. So we want to have tick. Then the water tile, I'm going to have serialized field float bob amount. It's maybe 0.1, and a bob interval of, let's go for 2. So then this will have a public override of tick. We'll run the base tick in case there's anything we need to do there. What I want to do is bob progress is 0. So we'll do bob progress plus equals time.delta time divided by bob interval. Now I want to keep that between 0 and 1. So I'm going to actually do bob progress is equal to that, modulus with 1. So it's always going to be between 0 and 1. Update the bob progress. I want to keep track of what my initial height was. So I'll have starting height. So that's something where I'm actually going to need public override void on instantiated. So we're starting to set up a couple of other little bits of logic. So we'll have in our base tile behavior a public virtual void instantiated, which this can then run that. So after something's instantiated, it'll be able to access that information. We'll run the base version. And we'll we'll actually grab starting position. So starting position is equal to, and we can grab our linked game object, transform position. So it means in our position here, update the position. So linked game object, transform position. We can change that. So that can be our starting position plus vector3.up by mathf.sign bob progress. Now sign takes it in radians. So mathf.pi times 2. So that should mean our water is bobbing. So it's how we can set up having different tile behaviors. So we've got our ones there. Now we have it set up for being able to tick it, but we haven't told anything to tick yet. So that's going to be the level parser's job. So in the level parser's update, it's going to check, well, if active level is not equal to null, then active level dot tick, and then our level is going to do a public void tick for each var row tiles in tiles, and it's just going to tick all of these. So for each var tile in row tiles, tile dot tick. So it gives us our update logic happening. Now this is very basic setup for that update logic, but it gives us something where the scriptable objects are able to control it. Now we can see, that movement is way too high. So what we're actually going to do is go to the water tile, and for one thing, we're going to switch, we want to use local position. Our bob amount, we're going to make sure we're multiplying by here. So bob amount times that. So the reason I'm working in local position is that everything the tile's doing should be local to its origin point, so I don't actually want it to be using world positions. And now, we've got our tiles bobbing. We could, just for extra effect if we wanted, we could set bob progress to a random range between, or random range 0 to 1. That would make it that they're all bobbing at slightly offset points, which might look a little better. So there we go. We've got objects where we're being able to load stuff from our level file, and it's now very easy. If I want to change my level, like, okay, well that's cool. Let's add in another section. Or let's add in after this, well, I want to have section of water here, ordered by rock. Very quick for me to just add that in. And when I add that in, I just go and load, and then I've got my different setup there in my level. So really quick, really easy for getting the stuff loaded in. Our logic is encapsulated in the scriptable objects. We've got some initial infrastructure there for pulling data in, for ticking them, and each scriptable object, it creates a unique instance that that tile is linked to. We've got decent naming for all of these, so they're very easy to go and then find if we need to later, which is great. So we've got key bits of our setup there for being able to extend this further. So in future updates, going to be extending on this, looking at things like being able to find all of the level files, being able to have some more sophisticated behaviors happening there, having them react to things in the world. So we'll have other bits that we're adding in later on, but this gives us a good starting point to go from. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, really helps out, really appreciate it. And if you're looking for the code for the project, the code is available up on GitHub, and you can use this code in any of your own projects, commercial and non-commercial ones, you're free to be using it. If you've got any questions, chuck in a comment below. And if you're looking for other ways to support the channel, I do have a Patreon, and there is a link for that in the description below. But until next time, bye.